Yeah, good afternoon all, and welcome to the lecture of 8085. And in this, we have almost completed all the programming structure, ICs, block diagram of 8085, and its instruction sets and some programs, hopefully 24 to 27 programs we have completed up till now, and that is what I have uploaded on my YouTube channel. Today we are going to start with another topic, that is the interfacing, right? So interfacing, I have given a little bit of introduction in the last class, in which I have told you why interfacing is required and what is the necessity of actually interfacing 8085 with the outside world, right? So that is what I have told you, and how many types of interfacing we have, digital interfacing and non-digital type of interfacing. That is what we have studied in the last class. Today we are going to start with a new topic, interfacing itself, but in that the main job of the PPI, that is Programmable Peripheral Interface, that is what we are expecting to start today. Uh, so yes, we I need to show you what IC we are expecting to study in today's lecture. So if you are able to see this IC, which is 8255, I hope it is not visible from with that screen, but it is that IC 8255, which sorry, this one is the IC 8255 which we are expecting to study today, and this is actually the port which is attached to this cable over here. This is connector over here, and from where we can input the data and we can output the data also, right? So this is that IC which we are expecting to study today. 8255, we call it as PPI, that is Programmable Peripheral Interface. And for that, let me share my screen. Yeah, so I guess my screen is visible to you all. Kindly tell me if it is visible. Yeah, so we'll
Yes, sir,
start with that.
visible.
Thank you. Thank you very much. So, myself, Dr. Andy Mishra, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science. And today we are going to study about the interfacing or the study of architecture and programming of ICs. Now, the main ICs that are being utilized in 8085, particularly for the need of interfacing or connection of the outside world. That is what we need to study today. So the main ICs that we use are 8255, that is PPI, Programmable Peripheral Interface. Then the other one is 8259, PIC, that is again for the interfacing of 7 segment display and that keyboard. Then we are having 8251 USART, that is Universal Serial Asynchronous Receiver Transmitter. That is also one of the IC that we use in 8085. Then we use 8279, that is for the keyboard display controller, and the 8254, that is the timer controller IC, timer and counter IC, which we require for interfacing with 8085. So these are the main ICs. There is one more thing for interfacing, that is AD and DA converter interfacing, right? So we require some of the data to be interfaced with the analog to digital converter and digital to analog converter. So these are some of the ICs, prominent ICs, which we basically try to interface with 8085. So these ICs are 8255. That is what we are going to study today. That is called as PPI, Programmable Peripheral Interface. 8259, that is PIC. Then 8251, that is USART. Then 8279, that is Keyboard Display Controller, and 8254, that is timer and counter IC. Then interfacing with 8085 with AD and DA converter interfacing. So these are all the interfacing portion that we are having, and we are trying to cover some of the portions in your Unit 4 syllabus of BSc Electronics, RTM Nagpur University. I guess this is the last. The new syllabus is going to start from this year, from first year, and of the Nagpur University. So we are learning this 8255, and we will be learning some of the ICs which we are going to interface. We need to learn about 8255 in depth, right? So we are going to do that. Then, yeah. So what is actually the IC? So yes, it should go up a little bit. Yes. So I guess it's not working. Uh, is it visible to you? What is it showing? Uh, yeah. So I guess, uh, yeah. So this was the basic structure of that, and this is the pin diagram of the 8255 IC. That is the block diagram of 8255 IC, which I expected to show you. Now, if you are able to say this, there are many ports, right? So the basic ports are port A, port B, port C. So we are having three ports. Now, what do you understand by a port? राइट द फर्स्ट क्वेश्चन इज व्हाट इज पोर्ट. हम लोग ये बोलते हैं ना, बंदर बंदर, या बंदर सुना है क्या कभी किसी ने? बंदर, पोरबंदर जो बोलते हैं हम लोग, व्हाट इज दैट? दैट इज कॉल्ड एज, इन इंग्लिश वी कॉल इट एज अ पोर्ट. हम लोग एयरपोर्ट बोलते हैं. व्हाट इज इट? एयरपोर्ट, वेयर द एयरक्राफ्ट आर सपोज टू लैंड, and from where the we can connect our country with the other countries, right? So that particular center of that is called as a port. Similarly, we are having a ports over here because we need to interface, we need to transfer our data from the one uh, point to the our 8085 to the outside world or to the interfacing units, right? So this is these therefore these are called as ports. So we are having almost three ports in 8255, in which 8085 are say 8085 are given the controls to control over this 8255, and we can program 8085 sorry 8255 through 8085 for the particular use of these ports, right? So for that we require some control word. Accordingly, we can use some ports A, B, C, and how you are going to use them. These ports can be used to give the data, that is to give the output through these ports. This can also be done. These ports can also be used to input the data, to take the data from the outside world. So in both the cases, we require these sorts of ports, right? So these ports are very essential to interface or to communicate with the other devices. So we are giving the data, or we are taking the data through these ports only. And whatever data we are going to input or we are going to output, we need to transfer from these ports only, and the accumulator plays the main role while inputting the data, similarly while outputting the data, because whatever data we are going to give, we have to give through the accumulator, and we have to receive the data through the accumulator only. So accumulator plays the important role. So first we have to put that data in the accumulator, then we have to transfer. Or say whenever a data is expected to come from the outside, we need to keep that data. We are expecting the data to be there in the accumulator first, then only we are able to process it, right? So accumulator also plays a very important role along with these ports, right? So we'll start with this. This is actually the block level diagram of 8255, in which we are showing you um, how the 8255 looks at a block level, right? So this is that 8255. So we are having these three ports: port A, port B, and sorry, this is port A, this is port B, and this is port C. So both all the three ports are of 8-bit, means the 8-bit data can be transferred and can be received simultaneously, whatever we want according to our requirements. So we use those. But the port C can again be divided into two parts. That is, port A upper and port C upper and port C lower. So we name it as group A, and if you are able to see my cursor, yeah, group A, that is port C, and group B, that is port C lower. This is port C upper. We use 4-bit, and we can use lower for 4-bit also. What it implies, yeah, what it actually means is this port C is a 8-bit, but we can divide this port C, port 4 bits upper and 4-bit lower as per our requirements, whatever we want. We want to program it first. So those are called as the control mode of 8255, and in which we need to give some control word. Accordingly, these ports are being defined, whether we are using those ports are input ports or we are using these ports are output ports or not. So all this is done by that control word. We've been looking at towards that also in the coming classes, right? So actually, we are right now we are concerned about the architecture of 8255. So we are working on that. So port A is 8-bit. Here the data can be received and data can be given. Port B is same. Port B is having 8-bit. Again, the data can be received and data can be given. So it can be used as an input port or an output port as well. Port C in that case is having a little bit of difference. Yes, of course it is a 8-bit, but we can divide again it to 4 bits, in which port C upper 4-bit is there and port C lower 4-bit is there. We name that as group A, and we can name it as group B. So along with port A, you can use this group A 4-bit of the port C, right? So these are ports. So these forms 24 pins of the IC, 8, 8, and 8. So 24 pins of IC. Then if you are able to see in between, we are having a 8-bit bus over there. So whenever where are there arrows are shown over there, so you can understand the direction of flow of the data. So in both the direction, the data can be flown. But here in the set word, the controls of group A and control of group B, you are able to see the arrows are coming towards these blocks, right? Both the blocks. What it implies is these ports, these group A and group B, can be given a control according to its requirement or according to the requirement of the user or the programmer, what he wants to do. So for that, you can give that control word to this control unit, and this is going to control the group A, and this is going to control the group B. So that actual control or the power word or the power code of that particular port can be given through 8085, right? So 8085 gives that command to the 8255 to know which port we are going to use as input port and which port we are going to use it as the output port, right? So we are having these 3 ports and then 2 control groups. Yeah. So in between we are having a 8-bit bus, internal 8-bit bus. What is it for? It is just for the transfer of data from one point to the other and inputting the data or the outputting data, like. So we are having that, and then we are having a data bus buffer over here, and this is that the data is being taken from the 8085 or from the outside world. So we are having this, yeah, this is going to the microprocessor, and these are the 8 ports which I had showed you that they are connected to this connector. So these are the 24-pin connector over here through which we can connect these ports, and accordingly they are being programmed. So this is the connection part. So this on the right hand side, which I am showing you over here, now these are given to the connector, right? Whereas this 8-bit are connected to the 8085. Now this is the read write control logic unit which controls this port A, port B, port C, and whether the data is to be read or data is to be written, right? That is being controlled by this read write control logic. So we are having these three terminals. Now these are controlled by the 8085, or say indirectly by the programmer, according to which we are expecting to use these ports, right? So we are going to give that control word through 8085 to the 8255, and then only we are able to use this, right? So the this is the read write control. Read means read, if you again see that, so read is complement, which implies that whenever this is zero, then only this is active. So these are active low, right? So read bar and write bar. So read and write bar are there. So we can see this. So read bar and write bar. Then we are having A1, A0 and reset. So A1, A0 are important control lines, and we are going to prepare one control word according to our requirement or according to our usage. So we are going to use this A1 and A0. So remember these two lines, they are very important. And then we are having this CS bar, that is chip select, and we are having a reset terminal also to reset whatever the control word is there. So control word can be reset. So one time we can program according as per our requirement, and then we can reset it, and then again we can use for the other purpose, right? So these lines are very important as far as interfacing is concerned. So this is the block level diagram of 8255. Again, we are having this positive 5 volt, that is the supply to be given to the 8255 and ground. So these are all the block diagram of 8255. I sometimes I will try to show you the IC pin configuration of that also. So we'll see that what is the pin configuration of 8255 also. So now for this moment, we are concerned with 8255 block level diagram. So in which I guess you have understood that we are having three ports: port A, port B, and port C, right? So port A is 8-bit, and that can be made as a control as a say input data or output data. So whatever you want, so output port or a input port. Similarly, port B. Port C can be used in two forms. Port C can be used wholly of 8-bit as for the output port or input port, or it can be divided into two parts again, 4-bit upper and 4-bit lower, and they both can be used as input port and output port as per our requirements. It has got internal 8-bit bus over here, and which gives the data, and these are these are the lines which are being given to the connector so that we can interface it with the outside world. So these are those pins, whereas this D7 to D0 bidirectional bus is coming from the 8085, which is going to control this 8255 as per the requirement, or say as per the requirement of the programmer. And these are the lines which we require. These are the control words, whether we need to eh, output the data or we need to input the data, and we are using it as an input or output. So that are controlled by these read and write signals, read bar and write bar signals. Then we are having A1 and A0. Now these are very important lines where we are going to give them according to the requirements of this. So it forms a control word, right? So I'll be showing you the control word, how 8-bit control word can be made, and accordingly they can be used as input or output. So these are there, and this one is the last pin is chip select bar, means whether this particular chip 8255 is to be selected or not, or some other chip is to be selected, that is being controlled by this chip select. So this is all about the block diagram of 8255. If anyone has any problem, kindly let me know. So we can push it to some more. So we are having some more data, that is actually the interfacing with 8055. This is how it is interfaced. And if you're able to see this, so this is actually the 8255 IC, and these are the control ports. These are the pins that we are having. PA, that is port A, which is having 8 pins from 0 to 7. Port B, that is 0 to 7, and port C 0 to 7. That is, there are 8 bits, right? And this is the data bus, which is internal database, which is connected in the kit itself. That is not internal, but that is connected in 8 lines from this 8085 to this D7 to D0 pin of the D0 to D7 pin of 8255. And these are those control lines: A0, A1, read bar, write bar, and reset. This is the chip select that is being controlled by the some other IC. So this is the interfacing portion of 8255 through 8085, right? So this block shows how this 8255 is being controlled by 8085, and whatever data is coming from this whatever data is coming from or going from this 8255 are to be first put in the accumulator in this 8085, right? So 80 in the accumulator of 8085 plays a very critical role in transferring that data from one point to the other, right? So this is how the interfacing is done in 8085. Now some of the theoretical part of 8255. So I guess this is pin structure of IC 8255. Now PPI is 855 IC is having in all 40 pins of 4 groups. So we are forming 4 groups. That is the data bus buffer 8-bit, which is going to 8085. Then we have read write control logic 2 pins. Group A, Group B controls. So we are having these as the third group. Port A, B, and C data bus buffers. So these are there, and this is a tri-state bidirectional buffer used to interface the 8255 to system data bus. Means this can be in say uh, bidirectional means the data can be transferred or data can be inputted or can be taken out from. So that is what it is called as bidirectional. In both the direction it is going to work. So this is a tri-state bidirectional buffer used to interface the 8255 to the system of data bus. Data is transmitted or received by the buffer on execution of input or output instructions by the CPU. CPU means 8085. Control word and status information are also transferred to this unit. So this control word, which I'm referring many a times, this control word is very important because we need to give that particular code which is going to determine which port is we are going to use as the input port and which port we are going to use it as the output port. So this is very important. So that is called as a control word that is also given through this, and the status information are transferred to this unit also. So we are having these 4 basic groups: data bus buffer, and then we have read write control logic, group A and group B controls, and then we are having this as yeah. So we are having this as the data port A, B, and C. So this data bus buffer, the first group is a bidirectional buffer, which I have showed you. Then, yeah. So the next one, which we need to say, is the unit accepts control signals, read write, and also inputs from address bus and say commands, uh, and issues commands to the individual group of control. So this is that group A, group B. It has the following pins. So these pins are also there. I have told you chip select. That is though it is active low. Read bar. I will show this is again an active board signal. Now this pin reads the data from the output. So this pin allows the 8085, that is CPU, to read the data in the ports or the status word through data bus buffer, right? Write again is active low, that is a low on this pin. The CPU can write the data to the ports, means to give the output from these ports to the control register through the data bus buffer, right? So read, write, and then we are having reset. A high on this pin clears the control register, and all ports are set to the input mode. So as soon as the reset pin is there, all the ports are being set again back to the as a input ports, right? So this is there, and then A0 and A1, these are address pins, and these pins in conjunction with read and write pins control the selection of one of the three ports. So that is basically forms the control word that we are going to work on. We going to know how we are going to design, or we can generate the code of that. So that is there. Now this is group A, and group B controls. These block receive control from CPU and issued command to their respective ports. Group A, that is PC7 to PC4. This is upper. So we are having two groups. Group A, port A, as well as port C, upper, right? So PCU, I call it as that. So we are having 12 pins over there. So group A consists of port A total of 8 bit, and port C upper, right? Port C, तो port A पूरा हो गया 8 bit का, और port C upper हो गया, right? So port C upper is also there, which starts from PC4 to PC7, right? So this is group A. Then group B is PC port C whole, and then we are having PC lower and a group C lower, right? So this is there. Then control word register can only be written into no read operation of the CW register is allowed, right? So status word operation of CW, that is actually the pin over there. So control word register can only be written into no read operation of the control word register is allowed, right? So this is there. So CW is that control word register. So ये सिर्फ लिख सकते हैं, कंट्रोल वर्ड क्या कर सकते हैं, हमको देना है 8255 को, ताकि उसको पता चले कि कौन सा पोर्ट इनपुट पोर्ट जैसा यूज करना है और कौन सा पोर्ट आउटपुट पोर्ट जैसा यूज करना है। तो हम उसमें कुछ और लिख नहीं सकते, राइट? हमको लिखना ही है, उसमें रीड नहीं कर सकते। दैट इज व्हाट इज रिटन इन द लास्ट लाइन। So this is, I guess, this is all for today's class, and we'll study this in the next class. So this is about port A, port B, and port C. I guess this is enough, and you have understood what is the interfacing of 8255 PPI, that is Programmable Peripheral Interface. And if you have any problems, you can discuss with me, and the platform can be set open for questions. So if you have any issues, you can uh, speak on this. Okay. So I guess there are no questions, so we can end the meeting over here. Thank you very much for joining today and bearing with me, because I have started a little bit of late, but still uh, I'm proud of my students that they manage or adjust these things. Thank you very much. Have a nice time. Stay home, stay safe, and take care. Thank you, Vishaka. Good day. See you soon in the next class tomorrow at the same time. Thank you. Good day. Bye.